In March 1986, at modeling events across the country, a revolutionary aircraft and concept were introduced. The concept, an easy-to-build, easy-to-fly sport jet that did not require the detailing of a scale model. The aircraft, the Bob Violett Sport Shark. Originally available in only one version, the Sport Shark met with such popular acceptance that two other configurations are now available. By stretching the fuselage 2 inches and sweeping the vertical fin, the Sport Shark swept fin was introduced. The latest, featuring the lengthened fuselage and a military-style vertical fin, dressed here in full camouflage, we present the Aggressor. Bob Violett Models is proud to present the state-of-the-art inducted fan technology, the highest performing model jet aircraft on the market today. Ladies and gentlemen, the Bob Violett Sport Shark. The tremendous power capability of the Biojet fan unit gives the Sport Shark the capability of climbing out approximately 4 seconds after the initial throttle up. This allows the Sport Shark to utilize the smallest of flying sights. And for those of you flying from a grass strip, relax. The Sport Shark doesn't recognize the difference. At speeds exceeding 160 miles per hour, the Sport Shark enters into a performance class never before explored in the history of ducted fans. The Aggressor demonstrates the handling capabilities with a high-speed 360-degree turn into a rolling vertical exit. With a thrust-to-weight ratio approaching 1-to-1, the Sport Shark defies the law that has required ducted fans in the past to maintain full power throughout the flight. Approximately 1/2 power is all that is required for most turnaround maneuvers. Listen closely and you will hear the throttle advance to full as this Sport Shark completes the turnaround sequence. In the climb out following the maneuver, Bob will select the appropriate altitude for exit and again bring the power back. For this maneuver, he will leave the power reduced. The maneuver? A snap to snap, rarely seen in ducted fan flight. The Sport Shark handles it without difficulty. The swept fin also returning to demonstrate its low-level, high-speed 360-degree turn. It is important to note at this time all versions of the Sport Shark perform identically. While leading the industry with its extraordinary performance, the Sport Shark will demonstrate another totally unique feature: slow flight. approximately 40 miles per hour, the Sport Shark will perform a horizontal figure eight without any tendency to drop a wing. This demonstration has given pilots the world over confidence in the Sport Shark's ability to comply with standard sport flying, landing, and emergency landing procedures. Available soon from Bob Violett models will be an exact scale F-86 and a F-16. Mr. Bob Violett.
Brief explanation of the fuel system. We have two what we call saddlebag fuel cells, one here and one on the other side of the airplane. These are specially molded fuel tanks such that they fit between the tailpipe and the fuselage, very close to the center of gravity of the model and on the same level as the carburetor. This fuel system is used in parallel and negates the need for any kind of an accessory or external pump on the engine. We use pressure from the pipe tapped off of the high point of the pipe into this T-fitting, two equal length lines into the overflow or vents of the tank, and then two equal length lines from the tank into this T-fitting and then into the needle valve assembly. So to fuel the airplane, we disconnect just short of the filter and we'll pump into the fuel lines. The tanks are 9 ounces apiece for a total of 18 ounces and a flight duration of 8 to 8.5 minutes with enough reserve to make a go-around or 2 or 3 if necessary. The tanks are translucent and we can watch the fuel rise in them. The overflow will go back into the pipe. We'd like to stop it just before it does, pull a little pressure back on the pump, and we can disconnect from the pump system and reconnect to the engine. To prime the engine, we have the radio on and we open the throttle, disconnect one of the pressure lines, hold your finger over the other one, and have your helper hold the tail of the model up a little bit. I'm going to raise the model, please. Now we're going to blow into this pressure line. It'll cause fuel to come up, go through the needle system and into the carburetor, and put a little fuel down into the engine for the start. See the fuel come through the line, reconnect the pressure line, and close the throttle. Maybe run it open 1 or 2 clicks for starting. To start the Violett, we have a special rod here that uses a ball end hex drive, a steel shaft, a brass bushing, and a cone that you apply the starter to. The push-in door on the side of the airplane is spring-loaded. It's just a piece of carbon fiber. We insert the rod through the door. You can look down through the inlets and guide the starter into the rotor bolt, or rotor retaining bolt. Now with the throttle set, a few clicks from closed rather, just a few clicks open, apply the glow plug heat, a regular 12 or 24 volt Sullivan type of starter. Hold the rod with one hand on the bushing, Hello, jet model enthusiasts. I'm Bob Violett. I'd like to spend a little time with you explaining what we've done here for the last so many years, developing a Violett power system and a series of kits to complement it. I'm going to first just give you an overall view of the kit, and then we'll spend some time looking at each individual part and try to explain why we did it, why it's a little different than what's already on the market, and how it can benefit you. Basically, we have a fiberglass group of parts here: the fuselage and the associated hatches, the inlets and the inlet lips, and the tailpipe sections. There are two sections. We have a clear plastic canopy option. We have the flying surfaces. All of the flying surfaces of the model are pre-built. These are the wings, the fin, the two stabilizers, and then we have die-cut parts that go in and form the formers in the fuselage, provide us with formers and mounting devices, strakes, wheel well liners, etc. The rest of the wood products for the elevators and the the rudder, and some leading edge pieces and some filling balsa, a few plywood parts. Then we have an entire group of carbon fiber parts that are specially made for this kit. This is what's very unique, and that we're using carbon fiber structure in this kit more so than has been done in the past. So we'll explain each of these parts and what they do. We have a very complete accessory package, the usual hinges and bolts and nuts and stuff you're used to. And then we have a set of injection molded carbon fiber parts that we developed especially for this kit. And these items are form what we call the hatch attach system and the cow keeper system that's used for access to the fan. Now, everything that I'm going to explain to you is already done in our very, very complete instruction manual. We have an introduction section, we have a warning and be careful section, we have how to sand the model, how to paint the model, etc. And then we get into this written description, and the most important part are the drawings here, the very comprehensive assembly drawings. Each step of the assembly, a lot of which I'll show you here during this film, is illustrated here in step-by-step assembly. There's no need for full-size plan with this model because the wings and tails and fuselage is already built for you. So remember now that everything that we talk about has been illustrated, described in a narrative, as well as described in photographs. At the end of the manual here, we have a series of photographs that describe which each of these drawings describe, only showing you the completed portions of the model and some more narrative description of each part. We even go so far as to give you what we call a first flight precautionary profile on how to get this model up and down on the first flight and be successful with it. Now, in particular, let's examine the fiberglass work. We're very proud of this work. It is done by a fellow that works for us named Bob Brown. He looks at each piece of work as a expression of himself and as a work of art. And when you take this thing out of the box and you look at it compared to anything else you've ever had, I think you agree that Bob really does a super job. Now, before we got to producing the fiberglass parts, we spent an awful lot of time on the plug, or what they call the buck, putting the detail and the special features into that plug that would show up in the mold, that would make your hobby and a lot more enjoyable, less frustrating, and a more pleasurable experience in assembling this model. For instance, the hatch is so important on a ducted fan model. The top hatch is molded as a separate piece. Now, heretofore in some kits, you have to saw this out, and then you would have to go in here with balsa wood and reform all of these flanges. Well, because we went to the trouble of molding it separate, these flanges are already formed on both the fuselage and the front and back of the hatch. So that saves you days of work right there. The hatch access panel for the radio and the retract in the nose of the airplane is also a separate piece. So you don't have to cut that out. And even the location and the clearance slots for the retract unit is scribed on the mold. Closely, a nice feature. You saw the airplane being started. We inserted a starting rod through the side of the fuselage, and the location and the form of that particular push-in door is molded in detail on the fuselage, such that you cut out this little rectangular section here, and you attach this piece of carbon fiber like so, and now you have a spring-loaded door that will push in and close automatically for the starting sequence. The alignment of the wing panels is very precisely molded into the fuselage. Now, this means that when the wing is aligned, and we actually use the fuselage as a jig to glue the two wing halves together, that the wings are absolutely aligned perfectly from left to right, both in pitch and in twist. In other words, they are absolutely perfectly aligned by the fact that these molding recesses here are done correctly for you. The necessary cutout for the wing access panel, or the panel that glues onto both sides of the wing, is scribed on the mold, as you can see, so it's easy for you to cut it out. We don't want you to have to figure out how to do this or where to do it. We've done it for you. So very precisely molded the location of the stabilizer spar inserts, and very importantly, we've molded these dots on the side of both sides of the fuselage, where the leading edge and the trailing edge of the stabilizer and elevator are lined up with these dots, guaranteeing you that the stab is on at the correct incidence angle. For the swept fin and aggressor version, we have molded the base rib pattern that matches the fin onto the top of the fuselage. So you just glue the fin right on here, and this gives you perfect alignment left and right of the fin. So what we've done here is we have guaranteed you a straight airplane, and that we molded, or we built the wings in molds, and then we gave you the alignment indices and saddle on the fuselage for the wing and tail. It's very difficult to build a crooked airplane with this system. Canopy detail is also scribed on the mold and therefore transferred onto the part that would allow you to just paint the canopy as it is, a fiberglass part, or cut out on these lines and replace with the clear plastic canopy that's provided in the kit. This is a nice option if you want to do some cockpit detail work, or in the most simplest case, just leave it off. In viewing the fuselage, undoubtedly you've noticed some yellow panels in the fuselage. Well, this is a space-age material that has a lot of strength in it, very good compressive strength and tear strength, and we've put these panels of Kevlar, DuPont's Kevlar, where we felt most necessary for, the maximum durability of the model should a bad landing occur. Kevlar is lighter than fiberglass. It's extremely expensive, and it's very difficult to cut, so that's why we can't make the entire fuselage out of it, but we use just the right amount where necessary to help make a better model. So that's the fuselage. And the other nice thing about good fiberglass work, and we'd like you to compare this, if you can pick the fuselage up at the show or next time you attend a fan fly and you sight down the side of the fuselage, on anybody's model you're going to see ripples, but not on our models. So we spend a lot of time block sanding out the plug and polishing the mold such that there are no ripples or defects in the sides of the fuselage. That's just a little bit of craftsmanship we like to pass on to you, and so that if you have the painting expertise and the time to do it, the model will be as good as you can possibly make it. We're giving you the model without ripples and defects. Okay, some more of the fiberglass components, and probably the most important part of any ducted fan or jet-powered any kind of airplane is the inlet system. Up to this point, this has been the most neglected part of ducted fan-powered airplanes. Some kits don't have any kind of inlet system in them, and when people ask, well, why does your airplane perform better than the others? They think, well, maybe it's just the airplane design, or it's the engine design, or it's the fan design. Actually, it's everything. But unless the inlets are designed properly and then molded such that you, the modeler, can install them without necessarily having the knowledge of why they work, the model is just not going to perform. So we went to a lot of work and a lot of trouble in engineering and designing and then molding and reproducing for you in the kit the complete inlet system. Now, every cross-sectional part of this inlet, every volume, every turn, every twist is very important, and it took a long time to develop this technology in the model airplane and pass it on to you. Very important also, besides the inlet tube itself, is the inlet lip, the very important curvature. Now, besides the actual inlet tube itself, and in of course the case of the Sport Shark, we have what we call a bifurcated inlet, or inlets that bring air in from both sides of the fuselage and are joined inside. A very, very important part of the inlet system is the inlet lip, and we mold this lip for you out of fiberglass in left and right pieces. And this lip is important, especially at slow speed, where we're trying to accelerate the model, in directing the air from the outside of the fuselage to the inside of the inlet duct itself. And you can see here against my jacket, you can see the cross-sectional shape of that lip. It has a very important curve. There's actually two curves involved there from a highlight on the outside. Now, this inlet tube has a recess molded in it on the inside here, and that inlet lip actually fits or keys into that recess. Now, we showed you the recess molded in the inlet tube. We also have a little step molded on the fuselage. Now, your job here is to cut out this section, and the cutout line is scribed for you, and you will leave this little step here. And after you've done that, then this inlet lip again will fit on the outside of that and join up with the inside that we showed you previously. Now let me show you what that looks like in the assembled stage. This is a partially assembled model. We'll refer to it a number of times in this presentation. And right now we'd like to show you that what I was just talking about with the inlet lip glued onto the fuselage, and then also the inlet liner itself glued inside the model, and how the lip very precisely joins the inside and the outside. Now, the reason that's so important is when the model is accelerating or standing still at full power, a properly designed inlet will actually pull air all the way from back here on the fuselage, and that air wants to negotiate that corner and come in and feed the engine. If that corner is sharp, it can't negotiate it, and it will separate severely off of that lip, causing a tremendous separation bubble in the inlet, and require that you either cut a hole in the bottom of the model or make the inlet larger. So as the model accelerates, this air is coming off the side of the fuselage, turning in here. As the model goes faster, of course, the air starts coming in more from a direct frontal entrance. And at full speed, the air is coming straight down the inlet. We'll talk about that more in the flying of the model. Here you can see how the inlets come together and have been joined. A little better view of it. The two inlet halves have been glued together, and they come together in a peak here, and then you can actually see this cylindrical area here. The spinner of the fan actually fits up in there, and the air is fed to the fan blades as precisely as possible. This black wrap that you see around the inlet, that is carbon cord saturated with Ca, and that stiffens. It's like forming a very stiff rib on the inlet, and that keeps the inlet from collapsing under tremendous pressure that the fan is exerting on it, or lack of drop-in pressure, really. The tailpipe sections that are precisely molded again out of epoxy glass. There is no joint or joining tape in here. We figured out how to mold these things such that you get a one-piece affair. It's very lightweight and very clean. The access hatch to the engine, or the rear of the engine, is very difficult to see on film here, but it is scribed in the mold, and it shows you where to cut that out. Now, the reason we have two sections of the tailpipe is that it's physically impossible to insert it in the model in one piece, so we had to mold it in two pieces. And to make it easier for you, we flared the front part of the rear section such that when you slide the two together inside the model, they will sleeve together just like that. It only takes a little bit of glue. Now, the shape of the tailpipe itself, the aerodynamic shape of that tailpipe is very important. And, you know, heretofore you've been given plywood pieces to roll up or plastic pieces to roll up. Well, the aerodynamics or the laws of physics that air is trying to obey as it proceeds under pressure from the fan down this tailpipe, it's important. And so we've taken the time to make the molds aerodynamically correct rather than just give you a piece of paper or plastic or plywood to roll up. So that's it for the fiberglass portion of the model. Now let's look at what we call the Magna-built or prefabricated, pre-built flying surfaces of the model. The wood group, or the flying surface group of the model now, you receive in the kit two pre-built, or what we call Magna-built wing halves, the fin all pre-built, and the two stab halves. The wings are built, the wings and tail surfaces are built in molds and jigs using balsa wood, a few plywood ribs, a lot of carbon fiber inside the model, carbon fiber spars that protrude out here. The control system is installed. A landing gear or carbon fiber flex plate is already installed in the model. We're going to show you a cutaway section just a minute here so you can see the details. These lines, along with the instruction package that we showed earlier, show you how to cut out the flap section and the aileron section and the landing gear wheel well. Now, already inside of each panel are the hinge blocks and the leading and trailing edges for the ailerons and the flaps. And then, of course, these are the locations of the hinges that you install. Inside of here is the landing gear flex plate system, and we're going to show you a cutaway wing in just a second. And then these are blade spars that actually join the two wing halves together. Now, it's very important to remember this model has a removable wing. The wing can very easily be bolted with 4 bolts taken off of the fuselage in just a matter of seconds. This is the control rod. It's already installed in the wing for the bell crank on the aileron. Now let's take a look at what this wing panel looks like as it comes out of or is partially finished as it comes out of our jig. You'll never see a lot of this in the airplane, but this is all inside of your model. We use a few ply ribs. We use lots of spars, as is the technique in full-scale fighter structure now. And we use lots of carbon fiber bracing that actually replace the many balsa wood ribs you're accustomed to. As we said, the bell crank system is installed, and the landing gear, this is a composite of carbon fiber and glass, all made in a press and processed. And this is what we call the landing gear flex plate. It is a perfect memory spring that's mechanically bound to the main carbon fiber spars. The landing gear actually bolts onto this, retractable unit bolts on here. And this will allow you to make just absolutely terrible landings and not hurt your model. This is a spring and it absorbs the shock. It is also very good for grass field operations. In designing this model, we wanted to emphasize the capability to use this airplane off the grass, and so we built a flexible landing gear mount system that will help absorb the shock of a turf operation. Inside the wing, after you cut off the aileron and the flap, these little pieces of wood are already in there, and they allow you to slice in and bury the hinges as appropriate into the proper blocks. Again, let me remind you that all the detail of what to do is explained and illustrated in the manual. The stabilizer sections, of course, they're much simpler, but they are built very similar with a couple of plywood ribs, and they have a lot of carbon fiber ribs and some spars in them, and these two little blade spars that protrude out each end, which we'll show you how that is inserted into certain formers in the fuselage. And the fin is a nice airfoiled affair. Again, a very simple structure using carbon fiber as the center of the leading edge, so you can sand this down into a very pointed affair, the same way for the stabilizer. So the real work of construction is already done for you. You do have to do some shaping of the elevators. And the reason the elevators are not pre-shaped is that there's a very, very thin slit in here which you'll insert a carbon fiber strip into. You'll zap that in there, and then you plane and sand the elevators to shape and put in the necessary blocks for the control horns. All explained in the instructions. Now, this particular package contains the die-cut pieces necessary for the formers in the fuselage and a few pieces in the wing, the wheel well liners, and the strakes. There are two types of strakes, depending on whether you have the aggressor model or the F-20 model. The strakes are simple little devices. It's really an option. We provide it in the kit. We provide the instructions on how to use it, and we provide some information as to why you would want to use them or why you may not want to use them. But they're little high-lift devices that project from the leading edge of the wing up to the fuselage. So those parts are in this bag. You've all seen die-cut parts before. These are nice quality ones, and they do the job. The accessory package is full of bell cranks for the flap installation, the nylon bolts, the hinges, the control horns, every nut and bolt and screw and fitting that is necessary to finish this model is in this package. It contains some very precisely, specially made parts, all molded out of carbon fiber filled nylon. These parts form the hatch attach group and the cowl keeper group. And they're molded just for this model and future Violett model airplanes. Now, this particular little part we call a hatch latch, and it's just a little spring-loaded device. It has a pin projecting out of here. It is mounted into the fuselage and supplies us the easy on-off release that you've seen in the operation part of the film. Then there are these hatch pins. They're little cylindrical topped, hollow cylindrical topped plastic parts and a pin base. And then the receptacle that they actually go into is also a specially molded part. And we'll show on this completed or partially built airplane here just how these pins are utilized and why we did them and why it helps making your fan model a little bit easier to work with. These little devices and the O-rings that come with them, we call them cowl keepers, and on the finished model we can also show you the operation of them. It just allows easy access to the fan system and actually inside the duct without the use of any nuts and bolts and rubber bands. I just don't like the looks of rubber bands on jet models. A very significant part of the Sport Shark series kits and any kit that the Violett product line will produce is carbon fiber. We have an entire product line of carbon fiber products called Violett. And when we first got into developing jet model airplanes, we found real weaknesses in the airframes when using ordinary products. Either they were weak or they were heavy. And once I was exposed to this space-age material, carbon fiber, it became obvious that it was going to have to become a very important part of our model airplane if we wanted to have a strong, lightweight model with various components such as a wing removable. So we actually, quite by mistake, got into the business of producing carbon fiber products, or the Violett product line, such that we could have these products available for our kits, develop the prototypes, and eventually manufacture the products for the kits. Now, carbon fiber has had some bad press in that it was associated with boron in one article written by what I feel very irresponsible journalist at Model Aviation a couple of years ago, where he actually got people afraid of the product. There is no, the only thing you can say about the relationship of carbon fiber and boron is that they're both space-age materials, and that's the end of it. We do not use boron, we use strictly carbon fiber in our Violett products. Here we have the two wing panels that have been joined using the fuselage as a jig, and joining the blade spars with the machine-cut carbon fiber composite angle or dihedral braces. Some of those little angles that we showed you are used here and here for the forward wing mounts, and used in the junction of the spars and the plywood rib to strengthen that joint. The aft wing mounts are carbon fiber blade spars with reinforcement on one side that are already installed in the wing when you get it. Carbon fiber again is used in the trailing edge of the wing so that we can sand it down to a very nice streamlined section. And again we have the hanger rash preventative type of structure there. This wing shows the wing wheel well cutouts, and visible inside are some of the carbon fiber reinforcements there. We've shown you the airplane, various component parts, shown you a little footage on the performance of it. If I've still got your interest, let me show you what makes the whole thing go. What we're showing you now are the various pieces and parts that come in the Violett fan-powered system, and exactly how they come to you. Let's start off by looking at the fan shroud and stator engine mount assembly. This is the way that you get the unit. Okay, we're going to look all over this thing and I'll try to explain it. We have first an injection molded carbon fiber filled nylon housing or fan shroud. On that housing, the engine mount lugs or fan mounting lugs are an integral molded part. You don't have to put them on, they're already there. The remote needle valve mounting bracket is already mounted onto the unit. The engine mount itself is an aluminum cast affair. As we're bolting the engine to aluminum, not plastic. We don't want to transfer the heat of the engine through the bolts into plastic, we transfer it into an aluminum casting. Now, attached to the top of that casting, or an integral part of that casting, is what we call the primary stator. The primary stator has the function, or similar function, of the other stator blades around the periphery here to straighten the flow, and just as important, and this is what's very significantly different about this fan, is that this stator spreads the flow as it proceeds back from the fan to the engine that sits back here. Now, we spread that flow to get it around that engine. Up in the top here you can see a little cooling duct. We take a little bit of that flow, or the necessary amount of flow, to cool the engine cylinder, the cylinder head. And then of course the engine fins will stick out just ever so slightly on the side here. So we'll get cooling there. We have all the cooling that we need. We're not wasting fan air to cool unnecessarily. Okay, so we have the engine mount, an integral primary stator, and the injection molded secondary stators. And this comes assembled just as you see it. And before this assembly is packaged up, it's put on a lathe, and this ring that the fan runs in is trued relative to the engine shaft, so that when you bolt the blade on here, it's perfectly centered in here. You don't have to do any sanding or refitting. We've done all that for you. You might notice these ribs on the outside of the shroud. These are just strengthening members that give the fan unit what we call hoop strength, such that it holds its shape. The fan rotor itself comes assembled, trued, and balanced exactly as you see it. The blades, although it looks like a one-piece out of the mold operation, the blades are molded individually, assembled on carbon fiber plastic discs with the spinner, and then a very precision machined aluminum rotor disc is screwed through each blade into the spinner. And then the blade is put on a lathe and trued and balanced before it is shipped out. So that's the way you get it. No assembly and no balance necessary. And of course the fan blade inserts in the shroud and spins like this. Now we're able to maintain a 15 to 20 thousandths gap between the blade tip and the shroud because the entire fan unit is mounted via these little pieces. It's sort of like a servo is mounted. These are rubber pads, and there are little rubber sleeves that go in here, and this bracket holds them all together. And this allows the fan unit to move very, very slightly in the model as the engine passes through its various vibration cycles during the throttle up and the throttle down. Any reciprocating engine has cycles of vibration. And it's not enough to disturb the model, but it is enough that if the rotor is securely bolted to the engine shaft, it's going to move. If we don't allow the whole shroud to float in there, we're going to eventually cause rub and wear and an increase in the clearance between the blade tip and the shroud. And that clearance is relatively important to the efficiency of the fan. This entire fan assembly design point was 85% efficient. That means we're converting 85% of the horsepower in to thrust out the back. The 15% that we'd like to think we could get to make a 100% efficient unit just can't be had because of the frictional losses of the air rushing through the ducts at very high velocity. That efficiency ratio is in the neighborhood of 15 to 20% better than the next best thing on the market, primarily because of the rotor design, a computer-generated rotor design that turns the flow into almost perfect axial flow, and because of the constant area ruling that we showed you as the air comes back over the beak or that primary stator, the the shroud itself is expanded out of round as necessary such that any cross-section through here is a constant area with any other cross-section at the same stage on another part of the fan. So, for all intents and purposes, except for the little bit of cooling air that we tap off as necessary to cool the engine, the fan blade does not know that the engine is sitting in the back. It does not feel the pressure of the engine in the duct, or the back pressure, which is a very measurable loss. After the fan air goes through the stator system, manages to cool the engine a little bit, as we've talked about. Then the fan air is picked up by these fairings. This one was mounted to the top hatch. It's removable from the airplane out of the tailpipe section. This top fairing is designed to take the flow as it comes off of the cylinder. It's a little bit turbulent in here. It straightens it back out and lets it enter the airstream again in a laminar flow situation. The center body, the air that comes off of the center body, that aluminum casting and the mount of the engine, is then streamlined by this fairing, which is another fiberglass part. We'll show you in just a second how you get that in the kit. And that flow is streamlined back into the flow to eliminate turbulence, to eliminate low pressure bubbles that are commonly associated with other fan systems. Now, since this one removes very easily with the top part of the exhaust duct, we also had to make this system removable and make it such that it wouldn't fly out the back of the tailpipe under a little vibration. So we manufactured the necessary brackets that attaches to the engine, and it's more or less an O-ring type of shock mount system that we can actually reach into the duct and just pull straight back, and that fairing will come off and allow us access to the carburetor. If we remove the tune pipe, which is an O-ring retained system, again all custom made to do the job properly, we now have access through the duct to the carburetor, any part of it. If we needed to, we could actually pull all the parts out of the engine through this access except the shaft and the bearings. Now these these fairings come to you molded out of the epoxy glass similar to the model, and the only assembly you have to do is bolt your engine in and do some minor modeling work to glue this fairing on and paint it, glue these two halves together with a former in there and the necessary retaining brackets. So it's not really much of a kit. The hard work has been done, the precision work has been done. The only thing we ask you to do is do a little bit of modeling with these fiberglass parts to form the fairings in the back. We use a remote needle valve system so that we can keep your hands out of the duct. You don't have to go in the duct fishing with screwdrivers or other devices to set the needle. It's all very conveniently on top of the engine, on top of the fan shroud. Here we can see that rubber mount system allowing the unit to move, and this is the throttle connection. This is the only thing that's in the duct that we would like to somehow get rid of, but we can't. It's the necessary little 55 thousandths diameter piece of wire that controls the throttle. Now, the KBV engine, as we said earlier, was developed by John Brodbeck and myself to do the specific job of powering a ducted fan model, and most specifically the Violett system. And we used the technology and some of the parts that they had developed for their boat racing 67, and we made every part in the engine as precisely as we could for the specific purpose of accomplishing this jet model propulsion. The engine case itself is not a bolt-together affair such as many. The actual front end of the casting and the main part of the casting is all molded in one piece, making a stronger, lighter unit. The material that's used in the engine shaft itself is a very, very tough to machine, but worth the effort, very, very strong steel. The ABC piston and cylinder has the proper taper in it, the proper porting in it to give us a reliable, high-power engine that will also idle in transition as well as produce approximately 4 horsepower. Ladies and gentlemen, I want to thank you for your attention and your interest in our project. We hope we've been informative here. We hope we've shown you what our efforts have to offer. We want you to become involved in this very interesting new facet of the hobby, ducted fan and simulated jet power model airplanes. The performance, the reliability, the enjoyment level is considerably higher than it was a few years ago. And we want you to get involved, whether it's with our product or some other product. We do invite you to compare other products. And that's what we're doing with this film, is trying to show you our products, emphasize what we feel is important, and we invite you to compare. And if we can be of any service to you, we certainly, that's our business. We want to. So enjoy the rest of the film. We got a little bit of hot dog flying, some precision pattern maneuvers on the film. Enjoy it, and if there's any questions that we haven't answered here, please feel free to contact us. Thank you.